Hello everyone, and today we'll be seeing one of the problem from Leetcode. It says minimum penalty for a shop. The problem goes like you are given a customer visit log of a shop represented by zero index string of customers consisting only of a character n and y. If ith character is y, then it means the customer came at ith hour, whereas n indicates that no customer came at ith hour. If a shop closes at jth hour, the penalty is calculated as follow. So there is penalty linked with the shop. So for every hour when the shop is open and no customer comes, the penalty increases by 1. For every hour the shop is closed and a customer comes, then the penalty increases by 1. So if a shop is closed and a customer comes, then there is a penalty, and shop is open and no customer comes, that means an idle shop, then there is a penalty. With this mechanism, let's see what we wanted to do. We wanted to return the earliest hour which the shop must be closed to incur a minimum penalty. Cool. Note that if a shop closes at ith hour, it means the shop is closed at the hour j. Cool. Now we have such a customer string within a sample input, and let's see how we got an output as 2. So you try to close it at 0, then you'll get a penalty of 3 because you have closed it right over here. So y, and y, 3 customers, you have missed it. And so if you close at 1, then you have 2 customer missing, and so on and so forth. You go ahead beyond. So if you close at last position, you see you have one idle shop that is at n, and that's the reason we can close the shop at n, because at point n it's the earliest thing. We are missing on upcoming y, but we are closing the shop early. So between the tiebreaker of 2 and 3, we chose 2. Makes sense. Now there is second case where everything is n, so no customer is visiting, so that makes sense to close right at the start. Cool. And there is also a case to close beyond the length of an array, which is 4. So we go ahead and we close it post everything is iterated. That does make sense. Now how to solve this? What can you think? So the basic idea of a penalty over here is you have to deal with two things. My previous ends, that means I have kept a shop open and no one came in, and upcoming y's. So this you can do with help of prefix sum, and you can get the understanding of, hey, what all previous ends I have did and what upcoming y's I have made. But and that kind of solution I have solved it already. So you can see submissions over here, and this was the solution at that moment of time. So it was 2023, and we just had an array where we counted from the right hand side, and once we got it, we chose a minimum, and then we proceeded with, hey, what is the minimum index which I can close my shop upon? And that's how we went ahead. But can we optimize this? Because this still needs a space complexity of O of n. Can we do this? Can we do this in a running fashion to count y and n? So can we do that? Yes, obviously we can do that, but let's make it much more simple than that. Let's not count y and n. The question wants us to calculate the penalty, right? To give us the index at the minimum penalty, right? So why not design a score based system? So why can't we design a score based system where if the shop is open and we see y, that's a plus, positive, and if we see n, that's a negative. And mind this, it is happening only when the shop is open, and that's what we are considering with this intuition. Can we do that or no? So with that thing, yes, that is possible, and we need to check the max score. So that would be our logic here, to check the max score, and based upon max score, let's fix the time to close, or I'll say best time to close. Best time to close. So that would make sense. Cool. How are we going to do this, and what would be the best time? The best time can be calculated one by one. So we are not in any kind of hurry right now. So what we wanted to do over here is, first of all, we have an array like this, or we have a string of customer like this, which is having 0, 1, 2, and 3. And we see y over here. That means yes, our customer is there at index 0. So we increment the count, which is 1. Right now we again see y. So it's a positive sign for us, right? So it's an increment of count 2. It's a positive sign. Now it's n. It's a negative sign. Now we wanted to decrement the count as 1. And now, well, mind that gap that here was the best time. Now there is y again, which is positive, and we have this. These two cancels each others. So we are in no intention to take the best time as later, but this point. Now 1 being the best time, we'll just go ahead and return that beyond 1 I'll close. So how would we do this? Return best time plus 1. So beyond 1 I'll close it, so I'll close it at 2. That's what we will be doing there. So far so good. Can this solution work? Is there any issues with this? Let's figure it out by implementing. I know that's not a good practice, but give it a thought for yourself. Do you see any issues with this? And let me know your thought process within the comment sections. Meanwhile, I'll start implementing the solution. I'll take int best time, which would be -1. Why -1? Is because if I mention it over 0, that means I'm closing the shop at 0. I don't want that beyond 0. I want to initiate it right now, that hey, I have not even began the execution, and that's the reason I'm using the number previous to 0, which is -1. Then I'll also have int score, which initially would be 0, right? Then I'll use int, or I'll use character s is equal to new customers dot to char array. It's better to deal with a character array than with a string. Then what next? Let's iterate. Now upon iteration, what I'll do is I'll take I is equal to 0 as less than s dot length I plus plus. Now I'm here checking that hey, if s of I is equal to y, then it's a positive score, else it's negative score. Cool. What does the positive score means? Is score plus plus and score minus minus. So simple. But if score is plus plus, it's better to check if score is greater than 0. and if it is greater than 0, I can update best time to I, and I can reset the score. Score is equal to 0, because I'm assuming here that hey, best time currently is I to close, and now I'm closing the shop. Let the score reset and let me see that hey, beyond this closure, can I get good results post this time? That hey, in short, I'm assuming that hey, I'm closing the shop at 1 right now, and let me see that hey, can 2 and 3 give me a good results? And if they does, then that's a good. When they will do, that's a good question. When they will do is, we will have a second case. Like when they will do means we would have a 4 and 5, which means y and y. Okay, pardon the capitalization, it's y and y. Well, in this case, if you're probing to close the shop right over here, that hey, I want to close my shop right here. Now I'll say that hey, close your shop. Let's assume that you closed your shop here. Let's see, at this point, are you able to continue your score or not? Are you able to gain anything from this score? And if you're able to gain this score, hey, close later. Don't close it now. Don't hurry up. And that's what I'm mentioning over here. And obviously, this is 2, and this would come out to 3. And that's when I say you don't close it right now. Close it at 4. See? But still we are not done with the array iteration, and next 3 would continue to 4, and I'll tell you that hey, don't close it right now and close it on 5, and ultimately your answer would be 5 plus 1 is 6 for this kind of example. So this is how the algorithm would go ahead and proceed itself. Ultimately I'll return best time plus 1. Why plus 1? Because we have already mentioned return beyond, I'll close at that best time. So return best time plus 1. Let's compile this code to check whether it passes the compiler errors. Yes, it does. A slight optimization I would mention in the end, so don't go anywhere. So good. It's efficient enough and beats 99.83. Can we do something more that it could beat multiple things, multiple submissions? Obviously, why not? You see, we are dealing with characters, and can we optimize that? Dealing with characters, can we do better? So yes, we can do better. Instead of operating with characters, which is heavy operations, we can operate with byte, which is, I'm taking S for now, and I'll take customers dot get bytes java dot nio dot character set. Don't worry if you don't know all those things, but these are the tiny bit of micro efficiency which you can get your hands into. Char set for name, and obviously this number, even I don't know, I'm taking this out from an article, ISO 8859-1. So once what this line does is, it line just simply converts string to not character array but byte array. Cool. So instead of that, we are using this, and instead of y, we can polish it much more in a way that instead of this y, we'll use this y, and byte y is equal to byte y. Okay, sorry. So let's try to compile this one. It compiles well. Let's try to submit this. Yo, it has submitted, it has passed all the test cases. Guess we are not that effective on the beating percent, but anyways, at least we have tried our best. The space complexity is definitely optimized, because in our earlier solution, which was made at 2023, it just used an extra space. But with this solution, we are not using extra space, and we are just sticking to only only the score based mechanism, which can give us right within one variable, which is score, the best time. And yeah, that's how it is. So this was a classic problem, dealing with, let me see topics, dealing with sum, strings, prefix sum. Obviously we didn't had any prefix sum array, but we used the same mechanism over there with the help of variable. And for more such prefix sum related content, click the video on your right, and I will see you in the next one.